Okay, so we are back here. We want to start. Now we want to talk a little bit about practical DevSecOps, how to start, what's DevSecOps, and how we can start, what tooling is available, and some just ideas how to sell it inside your company. We will see. So just one thing. First of all, if you have any questions, feel free to ask. We have two possibilities. One is during the talk, just write it into the chat, and later we will have some Q&A. So just feel free to drop in and unmute yourself and ask me the question if this is more convenient for you. So with unmuting, please do it after the talk, but I try to have a view on the chat so that I can react on questions if I see them. So now, again, some critical part here will be how to start my PowerPoint. I tried it, and here we are. So, oh, by the way, if it is more convenient for you, you can just ask the question in German as well. I will translate it, and then we'll just give the answer in German and English. So feel free, it's late, and we are all lazy. Just do it in a way that is more convenient for you. Okay, so here we are. I hope everybody can see my screen. So, and I'm searching for the chat window, but this is always hidden.
Yes, you are visible.
Perfect. Okay, so then DevSecOps. DevSecOps is a big topic now, and everybody's talking about it. Oh my God. So let's see. My name is Sven Ruppert. I'm working for JFrog. JFrog is the DevOps company, or maybe it's a DevSecOps company, and we just went to NASDAQ, so it was just an amazing event. And now I want to talk a little bit about the best practice, what we think could help you. So if you want to see more like this, and then in the forest, just search out for my YouTube channels. I have them in German and I have them in English. And otherwise, follow me on Twitter or LinkedIn. Please don't write me an email, because emails are just, I don't know. No emails, please. So, but Twitter and LinkedIn. So, okay, DevSecOps. Talking about DevSecOps means that we are talking about infrastructure, that we are talking about best practices, that we are talking about processes, behaviors, stuff to learn, black magic, like security, and so on. So to have a good entry point to start the discussion, or to start this, what's going on here, I just want to have as a basic idea something that's right now called Cloud Native. I don't want to go into detail from Cloud Native, so there are so many people that know way more about this one as I am, but I want to grab some highlights here that are leading immediately to the point of security. And it reminds me to some stuff that I saw over the last 20 years in the Java world a few times, but with different words. So Cloud Native, what they're saying here is, for example, with the service-oriented architecture, for sure, that means we are writing these microservices, and that's all fine. And then those microservices will start communicating with each other over an API. Why this is blue here in this slide? Because this is something that is generic. So you have this decomposing of your use cases, you have this split up in tiny parts, but what we are talking, everything that's coming below is the same more or less inside the monolith. So this Cloud Native is just a buzzword I want to start with, because there is it explicit mentioned, but the same stuff is available, or it's the same for monoliths or whatever architecture you're using. So don't be just have it in mind. So this, how to make a service-oriented architecture, how to split it, how to split use cases, and all this stuff. This is more or less something that is slightly touched by security in terms of technical security. And this API communication in between means that they start talking to each other, and then everything is running on the infrastructure, and it's some kind of Docker, Kubernetes, whatever. So it's here. And the good thing is, or what's interesting to see is that the Cloud Native Foundation switched the term from DevOps to DevSecOps. So they are explicitly talking about DevSecOps. So why we should do all this stuff? So for example, we are splitting all this stuff because we want to have shorter release cycles. So this time to market is critical from the business point of view. We want to have this short release cycles because short release cycles mean that we can deal with new versions, with bug fixing, with security issues, and so on. And they split up in tiny chunks will give us the possibility not only to structure it in a monolith, you have these tiny parts maybe as well, but you're splitting it inside this bigger thing, and then this big thing must be rolled up again and again. So maybe this is slow, but if you're splitting all this up, you have these tiny things, and then you can start updating them. And they are talking about this APIs. They can talk about different versions with each other. So this is a quite convenient thing. We had something similar with service-oriented architecture with the SOA, Corba, RMI, whatever. So we had always this way. We wanted to go to this distributed systems and this local transparency and all this stuff. But the technology evolved so that now we can do it more efficiently, and we can do it on our local machine. And 10 years ago, it was just not possible to do this microservice infrastructure on a local machine because it would just burn your laptop. But on the other side, you have now these tiny steps. And if you don't have these tiny steps inside a monolith, you have them in microservice, you're thinking mostly about a shorter lifetime because you are thinking earlier about rewrites. And this rewrites needs mostly, and in combination with this API communication, it quite often leads to this behavior that, wow, I can choose freely the technology I'm working with. That's good, that's bad. Bad in terms of if you're a Java senior developer, maybe in Kotlin you're just a junior again, you can transfer some best practice and knowledge, but you have to learn a new environment and new tooling and all this stuff. So the main thing is that you're talking about an earlier rewrite instead of maintaining, instead of refactoring this stuff. Refactoring anyway is a bad word, so rewrite sounds better. I don't know what's better to say to the management. But one thing is, if you're talking about DevSecOps and the security part, if we are now leaving this cloud native environment, we are just looking at one single microservice, this tiny thing, or this single monolith, or this single part, whatever. So one thing that is running somewhere. This is the smallest logical unit I want to have a look at. And then I have this part that I have some technical requirements and I have some domain-specific requirements. So the security part for the domain-specific requirements, there are regulations and rules, law, whatever. So this is one thing. But we want to focus on the technical aspect here because of the vulnerabilities, for example, or compliance. Compliance is a technical thing, more or less, after you decide what's a good license. But if you're looking at the single point now, what we have the basic application, and this basic application is then running on Linux, because this Linux we want to wrap in Docker, and then we want to orchestrate all this stuff in Kubernetes. So DevSecOps is leading over all these layers, but the main thing is we have some kind of hardware, this infrastructure. This could be infrastructure as a service, but it could be your own infrastructure, so this hardware stuff and so. This is why I'm mentioning it explicitly under this Kubernetes stuff. But what you could see is that the core of it, what we are writing, what you as a developer are doing on a daily life is you're writing code, and this is the first layer. Think about like onions. And if you have vulnerabilities or compliance issues in this, they are directly or indirectly in all other layers as well. So, and then this is a term, this is why people are talking about the term shift left. So if you're rotating now this picture 90 degrees, you have this shift left idea. And shift left means here, in this case, if you start working in this application, it's the farthest left point. You should start here with security. You shouldn't start with security inside your Kubernetes universe or inside your Docker. So it makes no sense to focus completely on firewalling and all this stuff in your Docker environment if you can have all this, or you can eliminate a bunch of vulnerabilities inside your application already, so that you don't need to harden against this one. So this is one thing. So if you start quite early as possible with security, means that all this stuff is not existing in all other layers. Great. And now you as a developer. Look, going back to this point where we are looking at the single point. The single point you have to write. What we're doing here is I start writing my application maybe in Maven. Okay, I know there's Gradle, there are some other things, but I'm old school, I'm old-fashioned, I'm using Maven. So I have this repository thing. So I'm dealing with dependencies here. So this application is dealing with Maven repositories, because I'm mostly working with dependencies. On the Linux layer, I have the same mechanism. I have this Debian repositories. On Docker, I have my Docker registries, and the Kubernetes universe is just opening the world to Helm charts. So it means with every layer, I have more complex environments, more complex technologies, and mostly I'm dealing more and more with dependencies, because I'm not writing a kernel driver, I'm using the operating system, I'm adding this dependency to get some functionality. But what the most people are forgetting is DevSecOps mean that security is part of everything, and the whole tooling stack is in some kind of repository as well, mostly in some shared folder, but it is some kind of a generic repository. So to have the round picture, so everything included, means that we have for every layer a dedicated technical repository, but for the whole stack that's holding it together, that's managing it, the whole DevSecOps part means the whole tooling is part of the generic repository as well, because security means that you should follow the paradigm of being immutable. Immutable means that everything must be there in an immutable version. And this includes the tooling as well. So if you have the JVM or the compiler or whatever tool you're using, it should be available and in some kind of immutable storage, or it should be stored so that if you're switching back after a few months, because you want to analyze what happened, why it happened, how to get rid of it, you need everything, not only the binary you're running, you need the whole infrastructure again. And this includes the tool stack again, so that you can reproduce every single step and to analyze it. So for this, you need something that can deal with more or less all repositories. For this, I'm personally using Artifactory. And Artifactory means that here I have the possibility to deal with all kinds of repositories. So he's able to understand this kind of repository. And on the other side, I can create my generic one. So I can just push my tooling here as well. And if I have the single logical point to deal with dependencies, I can plug in with a logical analyzer at this one in a transparent way. And this is called X-Ray in our platform. You need different possibilities to go through it. We have the web UI, but you can do it by REST API, you can do it with a CLI, whatever. But in the end, the main thing is why should I focus on dependencies? Why this is a low-hanging fruit? To explain this one, what I want to say is we have this time to market, and time to market in an economic point of view means that you want to have an idea, you want to create this use case, you want to write your code, and then it must be shipped to the customer. Because only if this part is at the customer side and the customer is using it, then he's willing to pay for it. Mostly, okay, we have some companies that are just buying software and storing it and paying over years, but mostly we have that use case, and then just if this is activated on the customer side, you're earning money. So this time to market is very critical from the management and from the salespeople. But for us as a developer, time to market is the same words, slightly different meaning, but with the same impact. Time to market, if this is fast, the whole production line, the whole process, everything around, not only the technical thing, means that if you need to have a change as fast as possible at the customer side, it would include version updates, security fixes, bug fixes, compliance changes, whatever. So we need a fast time to market, a short time to market. So we are talking about the same stuff, but with different impact. But it's the same mechanism. We are working hand in hand with sales, with the management, but sometimes just good to highlight this one so that everybody is really aligned on this one. But the main thing is make or buy. And even if this is an economic expression, for you as a developer, you are doing it every single day. You are having the decision, make or buy. Make is, you're writing it by yourself. Buy is, you're adding a dependency. So don't reinvent the wheel. And for security, it's one of the key messages. If you want to have DevSecOps, don't reinvent the wheel. Don't think you are so smart that you can beat the whole world. Learn from other people. Try to get best practices in. Use their tooling. Improve the tooling. Improve the composition. It's an ongoing thing because it's an always ongoing thing. Other people are learning every day and they will change their attack vectors. They will do all this stuff. So make or buy is one important thing. Having a look at the make or buy, the main thing is if you're now grabbing only for this tiny application here, and we are just shifting from application Linux, Docker, Kubernetes universe, and we are looking at this make or buy decision. Red is make, because of pain, you have to do something. Buy is just adding a dependency. Is that inside the application, the difference between make and buy is a completely different one compared to all other layers. So mostly there are some other environments where it's maybe a little bit different, but mostly I assume that inside the application, the code compared to the amount of dependencies is in a better value between each other compared to Linux. On Linux, the only thing you're adding is you're writing a config file. This is the only thing you're making, and the rest is the dependencies, the whole operating system, every service, everything. You're just adding configurations mostly. Same in Docker, you're writing a Docker file, but you're not extending Docker as a technology. Same with Kubernetes. We can discuss if you're on a Docker layer or a Kubernetes layer, you're pushing more in or out, but in the end, what you have is you have this make and buy. So we have two things that can be poison for your business if you're talking about DevSecOps, and you have to do it for your open source projects as well, and this is pain. The first one is compliance. Compliance means you have to deal with license. License is just, mostly it's boring, a lot of text, and what they are writing, I'm personally not able to understand mostly. And the main thing is you need some guidance, what is a good license, and if you decide you want to follow, for example, Apache license or GPL, whatever, then you must make sure that everything that you're producing for your open source project will have overall transitive dependencies value a license with the same value or with the same style or that are fitting together. So compliance, even for your open source project, is a thing. And the other thing is vulnerabilities. Vulnerability is just you have this vulnerability here, and then you need the knowledge there is, I don't know, some stuff in serialization or whatever. So compliance isn't one-time shot. So you're thinking about the compliance, you're deciding something, and then the machine should do the thing. So over the whole tech layer, over all layers. And vulnerabilities is a recurring effort. So it must be done constantly. If there's something you have to react, you have to do something, the machine is scanning, but the human is deciding, because you have to decide, oh, there's a vulnerability. Should I go with version up or down, or should I replace it with a semantic equal version? The good thing with compliance is, if you're looking at this one, you have just some spots with compliance, and they are poison in their region, but it's okay. In some, they're most likely not a big deal, but completely different with vulnerabilities. Vulnerabilities, they are just your evil. Why? You have them in different layers, and minor vulnerabilities can be combined to really bad attack vectors against your system. So you have to make sure that the vulnerability, not only in your source code, you must know them over all tech layers. And then the full impact graph is something you need to know. And this means you have to scan it over the whole thing. There's one thing with vulnerabilities, and this is even important if you're delivering open source tools or whatever software. There is this vulnerability found, then you have this timeline until this information is public available. It could be held back by the companies because they have some time to fix something or whatever. So to have this gap between found, before found, I have no clue about this one, but if it is found from some researchers or whatever, you have this time until it's public available. If this is public available, then you have this time between this information is here and this information is consumable for you as an individual one. So it means you are buying VolnDB as a resource, or you have some research papers at the university, whatever. So this information is now accessible for you, so you can deal with this. It's not only known, but you can use this one. Or for example, there is a fix, you can use this fix. So some kind of consumable. And what it mostly is that this period is not so bad, mostly, not always. I have this Apache project. There was a vulnerability, there was a fix, it was already merged. And then why they haven't done a release for 3 months or so? I have no clue. Well, it was one of this. No, you never know. But if you have this info, it's consumable for you. So this depends, is it fixes here, how long it will take to ship it to production. So, and this is so if you're looking at this one, it says found to public available. Most likely you have no impact here. You can't do anything. From information is available until consumable, you have some impact. You can ask on a frequent, higher frequent. You can pay for this information. You can, whatever it's possible. So you can influence it a little bit. But then the most impact do you have is from now it's available and consumable. Now I'm shipping it in production. And this is a thing you should focus on, because this is sometimes a quite long thing. So what should help to start with good DevSecOps means that the whole pipeline must be optimized or must be automated. So the CI environment is your working house. It's the same like DevOps. It's just, it must be automated. So this technical thing must just be fast. And the safety belt you have here is a good test coverage. So, and again, a good test coverage is just your safety belt. Why? Because dependencies are the most impact for you. So mostly, if you're talking about the dependencies, the biggest part in your whole application are dependencies. So scanning dependencies will have the highest impact in a short amount of time. It could be perfectly automated, and it's mostly some kind of free. So it makes no sense to analyze with machine learning your piece of code if your piece of code is just 5% of the whole stack or less. And just to have an idea about these different techniques, for example, if you're scanning your source code with machine learning, AI, or whatever technology, then we have to understand that this is a great way to go, but it will take some time until this technique is good enough. It's the same like with machine learning, I'm generating test coverage. There are some companies already with a bunch of money, but the results are, well, it takes some time. I'm not saying it's bad. I'm just saying it will take some more time. But if you're just looking at the whole stack, the dependencies are the big fish. The dependencies, just the dependencies, and scanning dependencies, scanning binaries is the easiest part. But you need to know how to combine all these binaries, the information about every dedicated binary, so that you can connect it to a full graph. So it makes no sense just to scan Docker image and see, and this Docker layer as a library. You need to know, oh, this library is in this Linux distribution, is in this thing, or this jar is now in this Docker layer, is used in this running environment. This is one thing. So dependency management has the highest and fastest impact. This is a low-hanging fruit. If you want to start with DevSecOps, scan your dependencies, go through the dependencies, because you can start immediately with this. You have different resources. There's one thing, if you want to try it, you can just think about, if you want to have the full impact graph, you need one logical instance that is understanding the full graph. So all technologies. With Artifactory, you have access to all these different kind of repositories, even with the generic ones, and X-Ray can scan it. So now back to the single point. If I know it from one single point or one single microservice, and I'm understanding Helm charts and Kubernetes universe as well, I have the full information about the full architecture and the dependency or the impact graph of the whole architecture. And this is just a huge thing. Even if it is in production, if you are able to scan and to verify this serialization plug is in this Docker image somewhere in this Helm chart. You know immediately where it is running, and do you need this Kubernetes administration webhooks this to shut something down or to change it. So you don't need to scan the production, you just need to know the whole architecture. By the way, if you want to see how to scan or to create vulnerability reports, I don't want to show here the screen and how to click here and there. I have this JFrog how-tos, just 5 minutes, 3-minute videos, check out on YouTube, German and English, and then you can see how to create a vulnerability report, for example, on the fly. Why? Because Artifactory and X-Ray you can get for free now. So if you want to scan your project, what you should do is just create a free tier and connect to this infrastructure. So one thing here is how it should look like. And the main thing is how it should be integrated in your world as a developer. You as a developer, you're sitting down there. And what happens mostly is that the CI part or just the security part is part of the CI only. And this is just a waste of money. Why? You have a proof of concept, you just start coding all this stuff, and you spend a whole day, and it's just fantastic, and you like your stuff, and then you're pushing it the first time to the CI environment because you need some stuff, and your proof of concept, you don't want to follow all this or ramp up. It will take maybe a day, or you have to request some stuff from some authority inside your company, whatever it's. So you just want to try it out, you spend a few hours, and then it turned out on the CI environment, well, there's a transitive dependency with a license, and you have to replace it. And then you're sitting down there and say, okay, there's no vulnerability, and it's perfect, but I have to replace this transitive dependency with a semantic equal version and the right license. And then you just lost a day. Quite often you can just start from scratch. It's the same with vulnerabilities. You are just checking a version, the latest and greatest, it's cool, and then you see, oh, there's something that's not fixed. But then you can check, okay, there's a fixed version. I'm just switching back. It's running as well, and I just have in mind that I can increase this version later and using other features. Just not now. I just have to go one minor versions back. So this information just in the CI environment would be just pain, or it's just wasting money. The best thing is if you have this information right now inside your IDE. So with this IDE plugin, we are delivering for IntelliJ, Eclipse, VS Code, and the good thing, it's open source. So if you want to change it, just change it, make a merge request. If you have an IDE, I'm not mentioned, just create a compatible plugin for this one. And the main thing is inside this IDE, what you will get, this is from IntelliJ, that you can connect to X-Ray. And with X-Ray, he's reading, for example, the full stack. So if you have a Maven dependency, for example, because you just start coding, it knows the Maven dependencies and will give you immediately inside the IDE the information. Wait, this dependency you have will have this transitive dependency, and inside this transitive dependency, there is this dependency that will have this security thing, or this compliance thing. So focusing on vulnerabilities, most likely this is the first thing people are interested in, is just checking for vulnerabilities. And then you have different possibilities. You can just say right-click include, and on the top level, you're just replacing the transitive dependency with an explicit dependency in another version. And again, TDD is your friend. Test coverage is exactly what's helping you now because you're changing the dependency graph, and that's it. The only thing that's a little bit bad is if you're reading this dependency graph and then you have this fat jar, and this fat jars are just merging these clauses in bytecode manipulation, then check if a tool is able to understand this and give you the right vulnerabilities and how to get rid of this transitive dependency with a vulnerability. It's pain. But fat jars are so nice these days. Think about if this is really worth. If you want to see this IDE plugin in action, just check out my YouTube channel, and then you will see how this clicking club. It's just 5 minutes, and then you see it. Okay, the next thing with security is if you're reporting security and there is no impact, then just don't scan. You need an impact. So it's with every report. If there's a report, nobody's consuming this report, nobody's taking action, just don't create this report. It's just a waste of time. Same with security. You need to know, or you have to check if your security tool you're using, in our example it's X-Ray, has some different possibilities. The most can just break a build or notify via email or whatever. But the really cool thing is if you're able to trigger webhooks, because with this one, you can activate workflows. So I have this vulnerability, I'm triggering this workflow will just take this one, pushing it to a quarantine repository, working automatically. For example, I have this Linux distribution, I'm just updating the libraries, checking it again. Okay, it's green, I'm pushing it to the next repository and it's consumable again. So you can play a little bit with this paradigm of virtual repositories to compose different variations of quarantine repositories and machine hardened or by the machine hardened dependencies. And the other thing is if you have to deal with compliance tools, then the webhook will say to a compliance tool, here's something, and the compliance tool can just grab all the informations via REST API out of it for reportings or whatever. Or what you can do, you can just reconfigure the whole pipeline of the whole JFrog universe over the REST API. So you're really able to automate all the things that you can follow the path. But for you, if you just have your open source, tiny thing for you at home, you have the dependency manager, you have X-Ray, you have it already inside your IDE. And if you need some information, for example, some versions or whatever, you can just grab it via REST interface out of it. Or you can just ping it with a webhook, a Docker reload or whatever. So this is a quite easy thing, and you should have a try. How to start and how to get it is quite easy, because you just go to javapro.com, start -3. If you want to see before you're typing all your stuff in, if you want to see what's coming and what questions are asked, I have this JFrog how to explicitly for this one, German and English. Again, I will show you how this process of free T activation is, so you can check what's going on, how it's done, how long it will take, 5 minutes or 10 minutes in total, including waiting of emails. And then you have a full stack with Artifactory and X-Ray and all this stuff. And if you want to have an overview of what you can do in this stuff without trying it out and giving your personal data, then just check out my platform overview how to. I will guide you to the main points and show you the things left and right. And for this, subscribe my YouTube channel, please. So what you should do if you want to try it out. So you have this artificial in X-Ray. What you can do, you can just create a remote Maven repository. Then you inside your Maven, you are just redirecting to this one so that everybody will be fetched over this repository. And if you have done this after adding a dependency, just Maven clean verify if you want to try it, or if you want to grab something over this repository. And then you can create watches. Watches is a thing how to make reports inside this platform. I have a YouTube video as well about this one. Otherwise, check with your IDE plugin immediately what's going on. An example, how to harden the Vardin stack is there on YouTube as well. So then you can see the practical workflow. It's just scanning for dependencies, changing them, rerunning your tests, and so on. And then just have in mind, if you have test coverage, it's nice. But if you have mutation test coverage, this is just awesome. Be aware, mutation test is just really, really cool. And this is helping. So quality and security is going hand in hand. And it's the same way. It's no dedicated security step. Security is like quality. It must be everywhere implemented. So this is one thing. Well, slowly, I'm coming to the point that I want to say thank you. There's a mailing list. You can register if you want to see on different things or want to check what my new videos are. The bad thing is that you're subscribing on YouTube. X-Ray looks familiar. Did it have a prior name? I have no idea if they renamed it. I just know it under X-Ray. But X-Ray is a common name in this DevSecOps thing. Nearly everybody is naming it with Ray, X-Ray, somewhere. Yeah, so thank you very much.